Hello friends, I am Snehal and I am teaching you physics. In today's lecture, we will see some more problems on one-dimensional motion. So let us start. Before we see problems, let me tell you about this concept called relative velocity. So suppose we have this straight road and let there be these two children A and B running on the road. So A is trying to chase B, Vb is velocity of B, Va is the velocity of A, and this O is the origin. Now we know how to find displacement. It is change in position and it is velocity multiplied by time. So I can write for displacement of B, position of B at some time t minus position of B at t equals to 0, and it will be equal to velocity of B multiplied by time. So it is Vb times t. Similarly, for A, I can write position of A at time t minus position of A at 0 is equal to Va times t. Now I will subtract these two equations. So xb at t minus xa at t minus this xb at 0 minus xa at 0 is equal to, on right hand side I will take that t common, so I can write Vb minus Va times t. Okay, so xb and xa are positions of B and A with respect to origin. If I want to find the position of B with respect to A, it will be this much distance, and it will be position of B with respect to origin minus position of A with respect to origin. So I can write position of B with respect to A is equal to position of B minus position of A. This is position of B with respect to A. It's the relative position. So I will use this notation here, and I can write xba at time t minus xba at 0 is equal to this Vb minus Va times t. So similar to position, I will say that Vba is relative velocity of B with respect to A. So it is Vb minus Va, and it is relative velocity of B with respect to A. So in place of Vb minus Va, I will write Vba. Okay, so this is relative position of B with respect to A at time t. This is relative position of B with respect to A at time 0. So position at t minus position of at 0 is change in position. That is the displacement of B with respect to A. So this is displacement of B with respect to A, and it is Vba multiplied by t. So I conclude that the relative displacement is equal to relative velocity multiplied by time. So relative displacement of B with respect to A is equal to relative velocity of B with respect to A multiplied by time. Okay, so relative displacement is relative velocity multiplied by time. We will remember this. Now this is the concept of relative velocity. Let's see one problem on this concept so that it will become clear. So let me erase this. Okay, so let's see problem number 1. Suppose there is a thief and a cop. So cop is trying to chase thief who is riding on his bike. So a cop in his car is trying to chase thief riding on his bike, and let's say there is some initial distance between cop and thief, and suppose it is 100 meters. Initial distance between the thief and cop is 100 meters. Suppose thief is going with the velocity of 36 kilometers per hour. The velocity of thief is 36 kilometers per hour, and suppose the velocity of cop be 54 kilometers per hour, and now we have to find the time in which cop will chase thief. So find time taken by cop to chase thief. Okay, so let us note down whatever we have here. We have velocity of thief, which is 36 kilometers per hour. Then velocity of cop is 54 kilometers per hour, and the distance is 100 meters. So better we convert all of them in same sets of units, that is SI units. So we know how to convert this. 36 multiplied by 5 divided by 18, and this is 2. So 5 2s are 10 meters per second is velocity of thief. Velocity of cop is 54 kilometers per hour, that is 54 multiplied by 5 by 18. So 18 3s are 54, 5 3s are 15, so it is 15 meters per second. This is velocity of cop, and the distance between them is 100 meters. So S equals to 100. So suppose thief, cop, and the distance between them is 100 meters. So now, relative to the thief, cop has to cover this much distance, 100 meters. So we can use whatever we learned. I can say S is the displacement of cop with respect to the thief. So S CT should be equal to velocity of cop with respect to thief, the relative velocity, multiplied by time. Relative displacement is relative velocity multiplied by time. So let's substitute these values here. So this is 100 equals to, this is Vc minus Vt multiplied by T. this is 15 and Vt is 10. So 15 minus 10 multiplied by t, it's 5. Let's take it on other side. So I can write t equals to 100 divided by 5, that is 20 seconds. Now let's see problem number 2. This is same problem number 1, and I am going to introduce acceleration in the problem. So now suppose our cop, who is already fast enough, accelerates and becomes super fast. Okay, so find time taken by cop to chase thief if the cop accelerates by 2 meters per second square. Now let's note down whatever we had. So we already found velocity of thief. Now I will make this initial velocity. So velocity of thief is equal to 10 meters per second. It was. Velocity of cop was 15 meters per second. We found it. Displacement to be covered by cop with respect to thief is equal to 100 meters. Now can we use the same formula that S equals to V times T? S and V are relative? The answer is no, because this formula was based on an assumption that the cop and the thief, both the objects, they are moving with uniform velocity. In this case, they are not. So what should we do? We have kinematic equation number 2. So what we can do is, we can write S equals to ut plus half at square, and we can make everything relative. Okay, so S of cop with respect to thief, that is displacement of cop with respect to thief, should be equal to initial velocity of cop with respect to thief plus half of A of cop with respect to thief. And we know what does relative mean. So this is, let's keep the same. This UCT is velocity of cop with respect to thief. So it is velocity of cop minus velocity of thief times t plus half. And this thing is acceleration of cop minus acceleration of thief times this t square. Okay, so let's substitute the values. So I can write S Ct equals to, okay, it was 100, UC is 15 minus U of t is 10 times t plus half of AC. Acceleration of cop is 2 meters per second square, so it is 2 minus acceleration of thief. So our thief is slow, it's not accelerating, so it is 0 times this t square. So that 2 and 2 gets cancelled. So we have 100 equals to 5t plus t square. We can take that 100 on other side. So we have this equation t square plus 5t minus 100 equals to 0. And solving this equation, this quadratic equation, will get the value of t. Okay. So this is how we use the concept of relative velocity as well as relative acceleration. Okay, now let's see problem number 3 on derivatives. So problem number 3 is the position time relation for an object in moving in a straight line is given by, let's take some relation, x equals to, let's say, 2 times t cube minus 5, and this is position, so it is in meters, and time is in seconds, so t in seconds. Now we have to find the velocity and acceleration for this particle. So find velocity and acceleration of particle at some time, let's take 3 seconds. So t equals to 3 seconds. Okay, so we know what is velocity in terms of position. So the instantaneous velocity is just derivative of position with respect to t. Instantaneous velocity v is given by this dx by dt. So let's substitute this formula for position. So substituting that, I get d by dt of 2t cube minus 5, and okay, instead of 5 let me take 5t here, so 5t. Now let us rewrite this, so it is 2 times this d by dt of t raised to 3 minus 5 times dt by dt. Okay, then dt by dt is obviously 1, d by dt of t. We know that if we have t raised to n, then d by dt of that t raised to n by power law is n t raised to n minus 1. So here the value of n is 3, so d by dt of this 3 t raised to 3 will be equal to 2 times the n, which is 3, into t raised to 3 minus 1, which is 2. So 2 into 3 into t square minus this 5. So this is equal to 2 times 3 is 6, 6t square minus 5. This is v. And position is in meters, time is in seconds. So units for velocity should be meter per second. Okay, so we found formula for velocity and it is time dependent. So at t equals to 3 seconds, we'll have to substitute the value of t to find out velocity. So velocity at t equals to 3 seconds will be equal to the 6 t square, and value of t is 3. So 3 square minus this 5. So 3 square is 9 and 9 6 are 54, I guess. Yeah, 54 minus 5. So this is going to be 49 meters per second. Okay, this is v at 3 seconds. Okay, now what about acceleration? So we know acceleration is just derivative of velocity with respect to time. So acceleration is equal to dv by dt. We will use this formula for velocity here. It is dv by dt. So it is t by dt of this thing, 6t square minus 5. Okay, now let us just rewrite this or separate this. So I get d by dt of 6t square, so it is 6 times d by dt of t square minus d by dt of 5. and we know that the derivative of constant is 0. 5 does not change when there is change in t, so this is 0. And derivative of t square by power law, here n is equal to 2, so it is 2t raised to 2 minus 1, that is 1, so 2t, 6 times 2t, and which is 12t. So acceleration is 12t meter per second squared, the unit. Now value of acceleration at t equals to 3 seconds. So it's going to be acceleration at t equal to 3 seconds is equal to 12 times 3, so which is equal to 12 3 is 36 meters per second squared. Let's see one more problem on derivatives. So this is problem number 4 and it is same as that of problem number 3 except for this x and t. Now I have changed the relation for x. Now it is a sine omega t. Notice that a and omega are constants, so a is equal to this 5 meter and omega is 2 per second. Why meter and per second? It's because the sine of omega t is dimensionless, so a should have dimensions of x, and that's why units of x, so unit of a is meters. And this omega t is an angle, so we know that angles are dimensionless. T has dimensions of time, so omega should have dimensions of inverse time, so time and inverse time get cancelled and omega t becomes dimensionless. That's why now omega has dimensions of inverse time, so this unit is 1 per second, per second. Then we have to find velocity and acceleration of this particle. So we know how to find velocity now. Instantaneous velocity is given by v equals to dx by dt. Let's substitute that value of x. So we get d by dt of a sine omega t. A will take outside, so it's d by dt of sine of omega t. Now how to find this derivative? It is function of omega t and we have to take its derivative with respect to t only. So if you are saying chain rule, then you have guessed it right. So let's recall that our chain rule says, suppose you have some function of u, then df by dt is equal to df by du, derivative with respect to u, multiplied by du by dt. Okay, here u is omega t and f of u is sine t, sine omega t, so it is sine u and u is omega t. So let's find du by dt. Du by dt is just d by dt of omega t. Omega is constant, we'll take it outside, so it is omega times dt by dt, which is 1, so it is omega. Then df by du, so df by du is d by du of sine u, and we know derivative of sine is cosine, so derivative of the sine u is cosine u, and u is omega t, so this is cosine of omega t. Okay, so df by du, our function is sine u and its derivative df by dt is equal to this df by du, which is cosine omega t, multiplied by du by dt, which is omega. So it is omega multiplied by cosine of omega t. So we have found derivative of sine of omega t. Let us write it here. So we have a omega into cosine of omega t. So this is v, and units, position is in meter, time is in seconds, so unit should be meters per second. Okay, now we wanted to find this velocity at t equals to pi by 6 seconds. So let us substitute that, and this a and omega, let us write it here. So we have v equals to a omega cosine of omega t, v at t equals to pi by 6 seconds. It is equal to that a omega, a is 5, omega is 2, multiplied by cosine of omega is 2, and t is pi by 6. So pi by 6, so that 2 gets cancelled with this 6, and we have 3 in denominator. So it is cosine of pi by 3. We know that pi radian is equal to 180 degrees. Say if we write it in degrees, we get 180 divided by 3, which is 60 degrees. So it is 5 2s are 10 times cosine of 60 degrees, and we know that cosine of 60 degrees is 1 by 2. It is 10 times 1 by 2, it is 5 meters per second. Okay, next thing we have to find is acceleration of particle, and it is similar to this velocity, except it is derivative of velocity. So instantaneous acceleration, a is dv by dt, and we have this equation for v here, which is a omega into cosine of omega t. Let us substitute this equation here. So d by dt of this thing, a omega into cosine of omega t. Now a is constant, omega is constant, so I will take them outside this bracket. So it is a omega multiplied by d by dt of cosine of omega t. And in similar manner, now you should convince yourself that derivative of this is going to be minus omega into sine of omega t by the chain rule. This is function of omega t. So let's say this is u. So derivative of cosine u is minus sine u. Then derivative of omega t with respect to t, it is just omega. So it is minus omega times the sine of u, which is omega t. Okay. So this is a omega square minus a omega square times sine of omega t. This is acceleration. Now let's find acceleration at t equals to pi by 6 seconds. So this is going to be a equals to a omega square minus a omega square into sine of omega t. Let's substitute the values. So a is 5, omega is 2, 2 square into sine of this 2 times pi by 6, so which we know is 60 degrees. This is 5 times 4 is 20, multiplied by sine of 60 degrees, and we know that sine of 60 degrees is root 3 by 2. So this is minus 20 multiplied by root 3 divided by 2. So 20 by 2 is 10. Acceleration is minus 10 root 3. and unit should be meter per second square. Okay, so problem 3 and 4 tell us that if we have to find the instantaneous velocity and instantaneous acceleration from position, then taking one derivative of position gives us instantaneous velocity, then taking two derivatives will give us instantaneous acceleration. Now let's see last problem for the lecture, problem number 5. So now suppose acceleration is given and we have to find velocity and position. So acceleration of a particle or object or body moving in a straight line is given by A equals to, let's take 3t meter per second square. T is time. If initial position of object or of particle is x naught equals to 2 meters from origin, and initial velocity u is equal to, let's take 3 meters per second, find position and velocity at t equals to 3 seconds. Okay, so we have a particle, we know about acceleration of that particle only, and we know these initial conditions. So x naught, the position, is 2 meters from some origin and initial velocity is 3 meters per second. What we have to find is velocity and the position at t equals to 3 seconds. So how are we going to solve this problem? So if you are saying integrals, then it's correct. Now this is problem on integrals. So we know the acceleration is equal to 3t meters per second square, and acceleration is given by dv by dt. It is 3t. Let's take dt on other side. So I can write dv is equal to 3t dt, and let's integrate this. So this integration will be from u to v. This 3 is constant, so I will write it outside integral. So it is integral of t dt from 0 to t. So starting time is 0 and this upper limit for time is t. Okay, now we know these integrals. So integral of dv gives me v. Between these limits u and v, and integral of t dt gives me t square by 2. So we know the formula. So it is 3 times t square divided by 2, and these are the limits 0 to t. Now let us substitute these upper and lower limits here. So substituting that, I get v minus u on left hand side. We substitute the upper limit, then minus the lower limit. It is equal to 3 times t square by 2 minus 0 square by 2. So it is 0. Okay, this thing is 0. So we have 3t square by 2. Let's take u on other side. So we have v equals to u plus 3 by 2 t square. Okay, so this is the relation for velocity, and we know what's the value of u. The value of u is 3 meters per second. So let's substitute it here. So we have v equals to 3 plus 3 by 2 t square meters per second. Okay, so this is how we find velocity given acceleration. Now we want to find the velocity at 3 seconds. So let's substitute the time in this formula. So we get v at t equals to 3 seconds is equal to 3 plus 3 by 2 times this t square, which is 3 square 9. So this is 3 plus 3 by 2 is 1.5, or the other way, this is 9. 9 divided by 2 will give me 4.5, and 4.5 multiplied by 3 will give me 13.5. So it is 13 plus 3 is 16, so it is 16.5, yeah, meters per second. You can check that. Okay, so we found the velocity at 3 seconds. Now we have to find the position at t equals to 3 seconds. So for that, we know we'll have to integrate velocity. So let me write v equals to dx by dt. So if I take this dt on other side, I can rewrite this as dx is equal to v dt. Integrating this, I get integral of dx is equal to integral of v dt. What will be the limits? So limits here will be from x0 to some x at some time t. We can write xt, x at t, and this v is, we have this equation for v, or this equation, it is 3 plus 3 by 2 t square dt. So time changes from 0 to t. Now we will separate this. So we get 3 times integral of dt from 0 to t plus 3 by 2 times integral of t square dt from 0 to t. Okay, now we know integrals of these things. So integral of dt is just t, and for this we know the rule, the power rule of integrals. Integral of t raised to n dt is t raised to n plus 1 divided by n plus 1. So here value of n is 2. So integral of this is going to be t raised to 2 plus 1 divided by 2 plus 1, that is t raised to 3 divided by 3. So this x minus x0 on left hand side, the integral will be x between these limits x0 to x, that is substituting upper and lower limit, we get x minus x0. This is equal to this 3 times integral of dt is t from 0 to t, then plus 3 by 2 times integral of t square dt is t cube divided by 3 from 0 to t. And because lower limit is just 0, we get 3t plus 3 by 2, or this 3 and 3 gets cancelled, it is t cube divided by 2 meters. Let's take x0 on other side. So we get x equals to x0 plus 3t plus t cube divided by 2 meters. So this is the formula for x, and we can substitute values of x0 and t here to get the value of x at t equals to 3 seconds. So x at t equals to 3 seconds is equal to x0, which is 2 meters. So 2 plus this 3 times 3 plus 3 cube divided by 2. This is 9 plus 2 is 11. 11 plus 3 cube is 27. 27 divided by 2 will give me 13.5. 13.5 plus 11 gives me 24.5 meters. So this is position at t equals to 3 seconds. Okay. So we find the velocity and position of the object. Okay, now we have solved quite a few problems on motion in a straight line. In next lecture, we'll start with motion in a plane. Till then, try some problems on one-dimensional motion. Thanks for watching the lecture.